Solving simultaneous equations algebraically. If we have a single equation which has two unknowns, like y equals 3x plus 2, there are an infinite number of solutions to this equation. So we could pick any three x values, and we've done this for drawing the graph. So we could pick x equal to 1, 2, and 3, and we work out the corresponding y values of 5, 8, and 11. Those were only three x values we picked, but we could have picked from an infinitely large number to put into the equation, and we'd have got a corresponding y value. If we were to look at a second equation, like y equals 6 minus x, again there are an infinite number of possible combinations there. So again, we could draw a table of values, x and y. We could have 1, 2, and 3. When x is 1, y is 5. When x is 2, y is 4. When x is 3, y is 3. And again, there are infinitely many. But what we can see is that there is one common solution. So 1 and 5 and 1 and 5 appear in both of those, and that would be the common solution. So whenever we're trying to solve simultaneous equations, we're trying to find that one or possibly two common solutions. So one of the methods we can use is graphically, but we've already looked at that. Another one is an elimination method, where we look at our two equations and we either eliminate one of the unknowns, either by adding or subtracting them. What we'll do is we'll start with two equations with two unknowns. We'll eliminate one of the unknowns and we'll have a standard linear equation, similar to 3x equals 12. And if we had that, then we could work out what x is, and then we could substitute the value back into one of the original equations to work out the corresponding y value. So we'll have a look at some examples and see that in practice. So if we have these two equations, 5x plus 4y equals 8, and 3x plus 4y equals 4, what we can do is we can try and eliminate one of the unknowns. What we can see is that both of the equations have a 4y. So let's see what happens when we subtract these two equations. So if we had 5x, take away 3x, that leaves us with 2x. And 4y, take away positive 4y. Now the take away and the plus is just subtract. So what we have is 4y take away 4y, which is nothing. And then 8 take away 4 gives us 4. So what we have then is that 2x equals 4. And if we divide through by 2, we get that x equals 2. What we can then do is we can substitute x equals 2 into any of the equations. So let's do it into 5x plus 4y equals 8. Let's call that equation 1. Then what we've got is, instead of 5x, we've got 5 times 2 plus 4y equals 8. So that's 10 plus 4y is equal to 8. If we bring the 10 to the other side, we get 4y equals 8 take away 10, which is minus 2, which means y equals minus a half. So it looks like our set of solutions are x equals 2 and y equals minus a half. But what we should do as well, just to make sure everything went right, is to check our solutions in equation 2. So equation 2 was 3x plus 4y equals 4. If we substitute in x equals 2, we'll get 3 times 2 plus and then 4 times minus a half. And that should equal 4. Let's see if it does. So 3 times 2 is 6. 4 times minus a half is minus 2. So we get 6 minus 4, or 6 minus 2 equals 4, which is right. So our answer is x equals 2 and y equals minus a half. In the second example, we've got 5a plus b equals 8 and a minus b equals 4. Now the last time what we did is we added the two, or we subtracted the two equations this time. If we were to subtract the equations again, what we'd have is 5a take away a is 4a. We have b take away minus b. When you take away a minus, that means you add. So you'd have b plus b, which is then plus 2b, and then you would have 8 take away 4 is 4. Now in this case we haven't eliminated the unknowns, so we haven't quite done that right. So what we need to do instead of subtracting the two equations is to add them. So if we were to then replace this with an add, we have 5a plus a, which is going to be 6a. We have b add a minus. Adding a minus is just a take away, so b take away b is nothing. And then we've 8 add 4, which is 12. And if 6a equals 12, a then is going to equal 2. So we can substitute this into the first equation. Into equation 1, let's call that 1, that's 2. Then we've got 5 times a, but a is 2, so 5 times 2, plus b equals 8. So 10 plus b equals 8. So b then is going to be 8, take away 10, which is minus 2. It's good to try and check that out. So if we check that out into equation 2, 2 was a take away b equals 4. A was 2, take away b, which is minus 2. So we've got 2 minus minus 2, which equals 4. 2 minus minus 2 is 2 plus 2, which is 4. So we get 4 equals 4, which it obviously is. So that means our answers were right. So a equals 2, b equals minus 2 is the only solution there. The third example then, we've got 5x plus y equals 22 and 2x minus 5y equals 25. And what we can see from the start is that the number of x's and the number of y's, there isn't the same number. So in the last two examples, the a's or the b's or the x's or the y's, there was one of them that was the same. So what we need to do is we need to try and make them the same. So if we wanted to make the x's the same, you'd want to get up to 10x. If you wanted to get the y's the same, all we'd have to do is get up to 5y. So the 5y is going to be the easier option there, because all we need to do is multiply equation 1 by 5. And if we do that, we get 25x plus 5y equals 110. And then equation 2, we can write that underneath as 2x minus 5y equals 25. Now, what we need to do to these two equations to get rid of the y's is if we add the two equations, so the signs are different, the signs of the y are different, one's a plus and one's a minus, and if you add those together, that'll get to 0. So if we add these two together, what we get is 27x equals 135. And if we divide both sides by 27, then x works out to be 5. So substitute x equals 5 into equation 1. So we've got 5x, so that's 5 multiplied by 5, plus y equals 22. 25 plus y equals 22. Take the 25 across and we get that y equals minus 3. Let's check that out in equation 2. So that's 2x take away 5y equals 25. That's 2 times 5. Take away 5 times minus 3 equals 25. So that's 10 take away minus 15 equals 25. And yep, that's right, because the two minuses make a plus, so you get 10 plus 15 is 25, and that's right. So therefore, x must equal 5, and y must equal minus 3. And the last example, well, it looks really different because we've got, on the first equation, we've got a y on the left-hand side and an x on the right-hand side. In the second equation, we have an x on the left-hand side and y's on the right. So it would be a lot easier to have the x's and y's on the one side. So we can rearrange equation 1. If we bring the y to the right-hand side and the 17 to the left, we can write equation 1 as 6x minus y equals minus 17. So that's, bring the y over, it becomes the minus y. Take the 17 to the other side, it becomes the minus 17. And let's call that equation 1. Equation 2 then, if we bring the minus 4y to the left, that will become 5x plus 4y equals 10, and that's equation 2. What we can do then, we can make the x's the same or the y's the same. We've done an example where we make the y's the same. This time, just to have a go at this, let's try and make the x's the same. And the x's the same, we'll have to go up to 30x. So if you multiply equation 1 by 5, that will give us 30x minus 5y equals minus 85. And if we multiply equation 2 by 6, we'll get 30x plus 24y equals 60. So now the x's are the same. What we need to do is either decide to add or subtract them. Now if we were to add the two equations, we'd have 30x plus 30x, which is 60x, so that's not going to get rid of it. So what we need to do then is subtract them. So 30x take away 30x is nothing. 5y take away 24, so minus 5 take away 24 is minus 29y. And then minus 85 take away 60 is minus 145. And if we divide both sides by minus 29, we get that y is equal to 5. So let's substitute in sub y equals 5 into equation 1. And we get 6x minus 5 equals minus 17. So add 5 to both sides, we get 6x equals minus 12. So x equals minus 2. So it looks like we've got a good solution, but we need to do a check. So we'll check in equation 2. And we've got 5 times minus 2. So that's 5x plus 4y. So that's 4 times 5. And we want that to equal 10. So 5 times minus 2 is minus 10. 5 times 4 is 20. So minus 10 add 20 does in fact add up to 10. So that's good. So our solutions then are x equals minus 2 and y equals 5. So another method we can use rather than elimination is to substitute. And what we do is we rearrange one of the equations so that we have one of the letters as the subject, and then substitute that equation into the other one. So if we do that with this example, what we can see is that the first equation, we have it already in the form of y equal to, so we don't need to rearrange it. So we can substitute that into the second equation. So what that means is we'll have 3x plus 4. Now instead of writing y, we can write 1 minus 2x, because that is what y is equal to. And then that equation will equal minus 6. So if we expand out the bracket, and then we'll collect like terms, but we've got 3x plus 4 minus 8x, so that's the two terms from expanding the bracket, equals minus 6. 3x minus 8x is minus 5x plus 4 equals minus 6. We could write that as minus 5x equals minus 10. So take the plus 4 to the other side, becomes a minus 4. And then divided both sides by minus 5, we get that x equals 2. If x equals 2, then we can sum into the first equation. So y equals 1 minus 2x. So y is going to equal 1 minus 2 times 2, because x is equal to 2, which is 1 minus 4, which is minus 3. So we've got that x equals 2 and y equals minus 3. Just like before, we can perform a check. So we can check in equation 2. So that's 3x plus 4y equals minus 6. 3 times 2 plus 4 times minus 3 should hopefully equal minus 6. Let's see. 3 times 2 is 6. 4 times minus 3 is minus 12. And 6 take away 12 is in fact minus 6. So therefore the solutions are indeed x equals 2 and y equals minus 3. So in this example we've got a minus 2b equals minus 10 and 3a plus 4b equals 4. So we need to try and rearrange one of the equations, and for one of the letters we could rearrange the second equation for a or for b, but that's going to be awkward. The easiest is the first equation and making a the subject, because all we need to do is move the minus 2b across. So if we rearrange equation 1, we get that a is equal to minus 10 plus 2b. And we can substitute that in to the second equation. So this is equation 1 and that's equation 2. What we get is 3 times a, which is minus 10 plus 2b, plus 4b is equal to 4. If we expand out the bracket, we get minus 30 plus 6b plus 4b equals 4. So that's 10b, take away 30 equals 4. So 10b equals 34. So b is 3.4. We can sub that into the second equation. And we'll get 3a, 4 times 3.4 equals 4. So that's 3a plus 13.6 equals 4. So then 3a equals minus 9.6. So then a is going to be minus 3.2. Let's check that into equation 1. So minus 3.2, take away 2 times 3.4 should equal minus 10. Minus 3.2 minus 6.8 equals minus 10. And that's right. So then the answers are A equals minus 3.2 and B equals 3.4. When we're trying to solve problems then, it's common to see problem questions that require the formation and use of simultaneous equations. So we need to use two different letters to represent the unknown quantities. We use the mathematical information to form two equations, solve them simultaneously, check them like we've been doing, and then use the solutions to make sure we answer the original equation. So in example 9 here, we have the sum of two numbers is 32, and the difference is 4. Find the two numbers. So let's call the two numbers x and y. What we know is the sum of the two numbers is 32, so that's x plus y must equal 32, and their difference is subtract. So let's say that x take away y then is 4. So we've got our two equations, and what we can do is we can either add or subtract to get rid of one of the unknowns. If we add the two equations together, we'll get x plus x is 2x, y add minus y, so that's y take away y, and that's nothing. And then 32 plus 4 is 36. So if x is 36, if 2x is 36, x should be 18. Let's sub that into equation 1, and we get 18 plus y equals 32. Y then is going to be 32, take away 18, which is 14. Just to make sure, let's check in equation 2. And we've got x take away y, so 18 take away 14 equals 4, and yeah, it does. So our two numbers were 18 and 14. So example B, 5 apples and 3 oranges cost £1.35. 3 apples and 5 oranges cost £1.45. Find the cost of 1 apple and 1 orange. So what we're going to do is I'm going to say let A be the cost of an apple. And I'm not going to do O because that might get confusing with 0. So I'm going to say B for an orange. And the cost for apple and oranges we'd imagine is pence. So we need to think about £1.35 as 135 pence and £1.45 as 145 pence. So 5 apples is going to be 5A, 3 oranges, 3B, and that's going to cost 135. Whereas 5 oranges, or 3 apples and 5 oranges is going to cost £1.45 or 145 pence. So let's identify them as equation 1 and equation 2. We need to try and get up to the same number of A's or B's. So let's get the A's to be the same. So if the A's are to be the same, we want to get up to 15A. So that means we'll multiply equation 2 by 5. And we'll get 15A plus 25B equals 725. And then equation 1 we'll have to multiply by 3 to get 15A plus 9B is equal to 405. If we were to add the two equations, that would result in 30A, and we're trying to eliminate that, so we need to subtract them. So 15A take away 15A is nothing. 25B take away 9B is 16B, and then 725 take away 405 is 320. Divide both sides by 16 and we get B equals 20. So we now know that an orange is going to cost 20 pence. To work out the cost of an apple, we will substitute B equals 20 into equation 1. That's 5A plus 3B's, so B is 20, 3B's are going to be 60. So 135. 5A then is going to be 135 minus 60, which is 75. So then A equals 15. So it looks like the cost of an apple is going to be 15p. But before we commit to anything, let's check in equation 2. And we've got 3A plus 5B equals 145. 3A's are going to be 45. 5B's, 520s are 100. That should equal 145. 145 equals 145, yep, so we're good. So the cost of an apple is 15p. The cost of an orange is 20p. The cost of one apple and one orange would then be 35p. Example C, a bag contains 40 coins, which are either 2p coins or 5p coins. If the value of the money is £1.55, find the number of each bag, or of each coin in the bag. So I'm going to let the number of 2p coins equal A, and 5p coins equal B. And the first piece of information says a bag contains 40 coins, so that must mean that A plus B is equal to 40. So the number of 2p coins plus the number of 5p coins equals 40. If the total value is £1.55, and that's 155 pence, then what we've got is the total amount of money of 2p coins is going to be 2A. The total amount of money from the 5p coins is 5B. and that will equal 155. So to get rid of an A or a B, what we can do is if we multiply equation 1 by 2, we get 2A plus 2B equals 80. And if we subtract those two equations, so 2A take away 2A is going to get rid of the 2A's, it's going to get rid of the A, and then what we're left with is 3B is equal to 75. If 3B equals 75, then B equals 25. So it would look like there are 25 5-pence coins. Substitute that in to equation 1, and that'll hopefully work out the number of 2p coins. So we get A plus B equals 40, A plus 25 equals 40, so A then is going to equal 15. So it looks like there are 15 2p coins. Let's just check, so it's always good to perform a check. Check into equation 2, so we've got 2A's, so that's 2 times 15, plus 5 times B, so 5 times 25. That should equal 155 pence. So 2 15s are 30, 5 25s are 125, and that should equal 155. And the left-hand side works out to be 155, as does the right. So it looks like we were correct. So we found that there are 15 2p coins, and there are 25 5p coins. And the last example, find the point of intersection of the lines with the equation 9x plus 3y equals 30 and 6x minus 2y equals 16. So the point of intersection is the solution to simultaneous equations. So if we write these out as 9x plus 3y equals 30, so that's going to be equation 1. 6x minus 2y equals 16, that's equation 2. We want to multiply them up to the same number. If we pick the x's, we're maybe looking at 18x. If we look at the y's, we're looking at 6x, or 6y, sorry. So that's the one I would choose. So equation 1, we're going to multiply by 2, and we're going to get 18x plus 6y equals 60. Equation 2, we'll multiply by 3, and we'll get 18x minus 6y equals 48. So actually it wouldn't matter which way we've done the equations to get either 18x or 6y, because we've got that anyway. And now it doesn't matter if we add or subtract. If we add together, we'll get rid of the y's. If we subtract, we'll get rid of the x's. But let's just do what we were going to do originally, so get rid of the y's. So we'll add the two equations. So if we add the two equations, 18x plus 18x is 36x. 6 plus minus 6 is 6 take away 6, so that cancels, and we're left with 108. And if 36x equals 108, divided by 36, we get x equals 3. Sub into equation 1, and we'll get 9x's, so if x is 3, 9x is 27, plus 3y equals 30. 3y is going to be 30 less 27, which is 3, so y equals 1. Let's check that into equation 2. 2 is 6x, so that's 6 times 3, minus 2y, so 2 times 1. We'd hope that should equal 16. So 18 take away 2 does in fact equal 16. So the equations match up. So then that means that the point of intersection, the coordinate, is 3,